Previously, we looked at how to implement a stack in Python. This involved creating certain essential operations involving pushing elements onto a stack and popping them off. In other words, adding elements onto the stack and removing them. In addition, we took a look at several secondary operations. These include how to print the stack, get its size, check to see if it's empty, get the top element, reverse the items in the stack, as well as get the minimum value. In this video, what we'll do is take a look at how we could check to see if, for a given string, if the parentheses in that string are balanced. So we want balanced parentheses. Now to do this, what we'll do is we will create another method for our stack. And so let's call this balanced parentheses. And what we'll do is, there's a couple ways of doing this, but the way we'll do it is we will use the stack to check to see if a string has a set of balanced parentheses. And so we'll need the stack itself, and then we'll also need an input string. So now that we have this, let's put pass. Now it's helpful to clarify what exactly we're going to do here. Essentially what we want to do is develop a method, and that method is going to take a string and it's going to tell us true or false if the string has balanced set of parentheses. So what does it mean for a set of parentheses to be balanced? Essentially what it means is for every open parentheses, there's a corresponding closed parentheses. And so this can occur in a couple different ways. We could have a set of nested parentheses like this, or if we wanted to use like curly braces and brackets, something like this, where these square brackets are nested in these parentheses, or even something like this. Here's another case where we have a string and we have the right nesting. For every open parentheses, there's the right kind of closed parentheses. But we also want to make sure we allow the string to say that a sequential set of parentheses is acceptable as well. So we'll permit this as well, that we have an open parentheses closed, open parentheses closed. So we'll say that these are all valid cases. In contrast, if we had, let's say, just a single open parentheses and there's not a corresponding closed one, so this would be invalid. If we had just a closed one, this would be invalid. What else? If we had an open one, but we had the wrong kind of closed one, this would be invalid. And then if we had some kind of mistake with respect to how they closed. So here's a couple key ideas that we need to also keep in mind. The first thing is that if we are reading from left to right, then whenever we encountered our first closed parentheses, that first closed parentheses should correspond to the most recent open parentheses. So if we are moving through, let's say we have this, and then we are moving from left to right, so we have an open parentheses and then another open one. When we encounter our first closed parentheses, this first closed parentheses should correspond to the most recent open one. So we get this right nesting behavior. And I guess the other thing to kind of keep in mind is the fact that when we have an open parentheses, so let's say we had this, that this first parentheses right here, parenthesis, this one actually corresponds to the one at the end. So that's another thing to keep in mind. Okay, enough introduction. Let's kind of code this up. So we want to have our method here take our stack that we have already, and then a string, and then it's going to return a Boolean value. And so I think the place to start would be to say, well, we need to capture the open and closed parentheses. So let's do an open parentheses, a kind of curly braces or brackets, and then a closed brace or bracket. And then let's do the right as well. So we need the right one, we need the right curly brace, bracket or brace, and then the square one. And then what we're going to do in order to use a stack to determine if the string has balanced parentheses is we're actually going to create a stack, and this stack is going to contain left parentheses, or like these kind of scope operators, as soon as we encounter them. So when we encounter one of these in our string, we're going to actually push it onto this left stack here. So for that, we're going to instantiate our class here, this stack. Now that we have this, I think our approach should just be to take the string and loop through it. So we'll say for character in our string, what we want is that if the character is in the left, so if it's in this part of this left group of parentheses, then we want to push it onto the stack. So we want to say left stack, and then we want to say, well, this left stack here, we want to push it onto the stack. And what do we want to push on the stack? We want to push the character. So we have this character right here that is part of this string. And when we encounter it, we want to push it onto this left stack right here. So if we encounter one of these, push it onto the stack. And so just as an illustration, let's say we had a string and it looked like this. Well, when we encounter this first one, it would get pushed onto our left stack. And if we encounter the second one, it would get pushed onto the left stack. But if we were to encounter something like A or this closed parentheses, these would not be pushed onto this left stack here. The next thing that we want to do is, if instead of encountering the left one, let's say we encounter the right parentheses. So if the character is in the right parentheses here, what we want to do is a couple things. The first we want to do is to check to see if this left stack is empty. So we have, let's say we encounter this, let's say we encountered actually just a right parentheses. Well, if we just encountered a closed parentheses and there's nothing in this left stack here, then we would know immediately that the parentheses are not balanced, because we would have a right parentheses, this closed parentheses, without any corresponding parentheses to close it. So if we ever did encounter that, we could say that we can immediately return false. So what we want to say is, if left stack is empty, this is a method that we developed earlier, and we will want to return false. Okay, but let's say we do have something in our left stack here. What we want to do is we want to check to see if the topmost element in this left stack corresponds to the character that we're evaluating. So what we want to check is, if we encounter this right parentheses right here, what we want to do is pop from the stack and check to see if this right parentheses here is this left, corresponds to a left parentheses. So we want to see if they have its matching pair. So what we'll say is that if the right dot index of the character, so what we're saying here is that we have this right string right here, and we want to get its index. So let's say we have, this close parentheses right here. We want to take this character and we want to see what its index is in this right string right there. And so in this case, if we had this, it would be 0. If we had this square bracket, it would be 1, or it would be 2 actually. And then if we had the curly braces, it would be 1. So we want to get that index, and then we want to compare it and check to see if it's not equal to the left dot index. So we want to get the corresponding index and see if those numbers match. So we got 0 right here for this closed parentheses. We also want to get a 0 from this left one right there. So what we want to do is get the left index, the index of this left one, and the character that we want is, we just want the element that is on the top of our stack here. So we can get this by just taking our stack and popping it off. So what we're doing here is, remember, we're added a bunch of items. If we came across, let's say, a left parentheses here, we kept adding things to the stack. And so let's say we had, I don't know, this. And so our parentheses right here is on the top of the stack. And then when we encounter a right parentheses, we want to pop this element off and then match them and see if they match. And if they don't match, then what we want to do is we want to return false. So it's only the case if they do match that we want to kind of keep going here. And then the final thing that we'll want to do is, so these would be the cases if we encounter a left one and a right one. Everything else we pretty much can ignore. And so the only thing we want to do to wrap things up is to say that we want to check to see if that left stack is empty. So we can use this is empty method that we developed. Okay, so the thought process would be if we encounter all of these open parentheses here, whenever we encounter a right parentheses, we know we can pop it off and compare them. And then in popping it off, we are just going to dismiss that right parentheses, but then we're going to have these two left. And so what we want is another corresponding open parentheses here. And if we encounter that, then we would pop it off. And if our string had another close parentheses, then we would pop that one off as well. Now, if we were left with this open parentheses or curly bracket right here, if we still had this, then we would know that there is an open or left parentheses without a closed parentheses. So we would know that there is not a case of balanced parentheses there. So now that we have this, it's helpful to have some tests to make sure what we did was correct. And so here I have a bunch of tests to check to see, one, if we get the right answers, both positively and negatively. So with respect to the positive test here, you could see I have just a kind of simple open and close parentheses. Then we have a case of nested parentheses. We have a case of sequential parentheses. And then we have some stranger cases, which should give us true, which is no parentheses, just a character with, which is W. We have some parentheses with a number in between. And then we have a case of nested parentheses with some characters there. So all of these should come out as true. Then we have some negative tests here, but let's run the positive test first before we get to those negative tests. So to create the test, we can just use a print statement. So we'll say for I in, I don't know, let's start with the positive test. Positive tests, we want to create a stack to instantiate our class here. And then we want to print something. We want to, how do we call this? We want the balanced parentheses, and then we want I for each one. So what's going to go on here is we're going to loop through each one of these positive test cases. We'll create a stack, and then we will make use of this method here. And the string that we add to the method, which this method requires this string, will be the item drawn from our set of cases. And so what we will have is, should have a big long list of all true. So let's go ahead and run this. And that's what we get. We get true for each one of those, which is the right result. So now to check the negative test, let's just change this loop to loop over this negative list. And what we have here is, again, we have an open parentheses without a closed parentheses. So this is not balanced. This would be just a closed one. Here we have a case where there actually is an open and closed parentheses, but the problem is we have a closed parentheses without a corresponding open one. So this is not balanced. Here we have the other result, which is an open without a closed. Here we have a case of there's the outside parentheses are balanced. These square brackets are balanced, but we have an open parentheses on the inside, which doesn't have its corresponding closed one. And we also have, a set of almost a kind of complete sequential set of parentheses, but it ends with an open parentheses without a closed one. So we should have 1, 2, 3, 4, 5, 6. So there should be 6 negative cases here. So all 6 of these should come out as false. And so let's run this. And that's what we get. We get false, 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 false. So this is how you might utilize a stack to check to see for a particular formula or string whether or not it has a set of balanced parentheses.